So today we are going to discuss how to convert a concentration of H plus into pH and then pH to H plus. We actually use this equation pH is equal to minus log of concentration H plus in the aqueous solution. This is the equation which we are using in order to convert the concentration of H plus into the concentration of pH. Okay, so first of all, let's look at simple examples where we have to convert 0.1 mole per cubic decimeter H plus, right, into a pH value. So what is pH? pH is a different representation of the concentration of hydrogen. So it makes it easier for us to track the values of the concentration, like measuring the acidity of the solution by using pH easily, right? Rather than having a lot of decimal numbers, it's easier for us to do it like that. Now here, 0.1 mole per cubic decimeter, if you want to convert to a pH value, first of all, we need to convert this to a something like this, right? 110 to the power minus 1. We can write it like this, right? So we can apply log into this. If we apply just log without applying minus log, what you will get? Minus 1. 110 to the power minus 1 log value is minus 1, right? So it's like this 110 to the power 3 log value minus 3 log value is, it's 3, right? Right? 110 to the minus 3 log value is minus 3, right? So let's say 110 to the power 2, then the log value is 2, right? So if it was like 310 to the power 2, what is the log value? The log value is 2 plus log 3, right? 2 plus log 3. That's how it comes. So now I have log value which is equal to minus 1, and then we are going to change the sign because we are applying minus log, right? So that's the total pH value. So if we are applying minus log, then the minus 1 will be converted to plus 1. So actually 0.1 mole per cubic decimeter, when it converts to a pH value, it will be 1. So next, if we look into the value which we increase the decimal point by 1, so you have 0.01 mole per cubic decimeter. You convert this to 110 to the power minus 2, and then you apply log into it, and then you have minus 2, and then you apply minus log to it. You convert the sign to a plus value. So you have 2 here, right? That's the pH value. Then third one, if we have 0.001, then we convert it to a scientific notation like this, and then we apply log, which is equal to minus 3, and then you apply minus log, where you convert that to a positive value. So you have 3 here, right? So Lamai, when you want to convert a concentration of H plus into pH, you actually need the logarithmic table, right? You need the logarithmic table. And also in GCE advanced level syllabus, most of the questions have these log values. So I want you to remember these values. Actually, it's not necessary, but it'll reduce the time which it takes to go and check the logbook, right? Log 2 is equal to 0.3010, and log 3 is equal to 0.4771, and log 4 is 0.6021, and then log 5 is equal to 0.6990. So it's better if you can remember these things. If it's not also, it's fine. You can use the logbook because they are giving the logbook in the exam, so doesn't matter, right? Okay, so let's find the pH value for this concentration, 0.02 mole per cubic decimeter. We want to find the concentration. We want to find the pH, right? So if we apply this equation, pH is equal to minus log of concentration of H plus, right? Minus log of concentration H plus. We can write this. First of all, now 0.02 is 210 to the power minus 2, right? It's 210 to the power minus 2. So if you want to convert this value, now we use that value right here. So we had 10 to the power minus 2, it became 2, right? If we have 10 to the power minus 2, it became 2, right? So here also it becomes like that. It'll become 2 here. And there's an extra term here too, right? There's the extra term 2 here. So for that, what we are going to do is we are applying minus log to it. So actually pH is equal to minus log of concentration of H plus, right? So we apply minus log. So we have minus log 2. So 2 minus log 2, right? 2 minus log 2. What is log 2? 0.3010. So if you don't know that, you can use the what you call logarithmic table, right? You can use the log table. So log 2 is, here you go, 0.3010, right? Log 2 is 0.3010. You can get it using the logbook as well, right? So we have 2 minus 0.3010, which is going to be equal to 1.6990. That's the answer for this concentration. That's the pH value. So I'll mark this as number 1. So after that, shall we convert 0.025? Let's say 0.025 we want to convert. Now here also we first of all write it in the scientific notation. Mole per cubic decimeter value, we are writing it in 2.5 10 to the power minus 2, right? 2.5 10 to the power minus 2 mole per cubic decimeter. Now we want to convert this to pH. So pH is equal to minus log concentration H plus. Now it's going to be 2 here, right? So we are going to write 2 minus log of 2.5. Now my log of 2.5 means you can check it if you want using the log table. No issues with that. So log table, log 25 is 3979. So that's also possible. That is also possible. 3979 is the answer there. So we can write it like log 2.5 as 2 minus 0.39, it's 75, right? 3979. Okay. 0.3979. And then we can have 1.6021, right? 1.6021 is the answer. Now, if you don't have a logbook near you, if you don't have a logbook near you, what you're going to do is you're going to expand this log 2.5. Now we already know the log value of 5 and log value of 2, right? So 5 divided by 2 is how much? 2.5. So if you are lazy to take the logbook out, what you can do is you can expand this and write. Now this is not necessary. I tell you, we can find the pH using the logbook, but this thing is not necessary. So we can write this like 2 minus log 5 over 2, right? Log of 5 over 2. Now log of 5 over 2 is log 5 minus log 2, right? Now we know 2 and log 5 value, I taught you that 0.6990 and log 2 value is 0.3010. So when you simplify this, you will get your answer 1.6021. So if you're lazy to take the logbook out, or let's say like you don't have a logbook near you when you're practicing the question and you see 2.5, you can do something like this. It's not necessary, but good to know, right? It's good to know. So let's look at another example where we have to convert a value like this. Let's say third one, 0.00003, right? 0.00003 mole per cubic decimeter. So let's say like, first of all, we have to convert it to a scientific notation. So 3 into 10 to the power 1, 2, 3, 4, 5. 10 to the power minus 5, right? 3 10 to the minus 5 is the value. So now if we want to convert it into a pH value, first of all, we have 5. So that means it's going to be 5 minus log 3, right? 5 minus log 3. Not as hard, right? It's not hard. So 5 minus log 3, 5 is, log 3 is going to be how much? Log 3 is going to be 0.4771, right? 0.4771. So you have 4.5229, right? 4.5229 is your answer. So that's the pH value. So let's look at another example. Let's say something like very awkward. Let's say like 0.000729. Okay, now this is not a standard value, so we have to use the logbook here. Here also we are using the scientific notation. So 7.29 into 10 to the power 1, 2, 3, 4, 5, right? 10 to the power minus 5. So 7.29 10 to the power minus 5 mole per cubic decimeter. We have to convert this into a pH value. So pH is equal to 5 minus log of 7.29. What is the value of log 7.29? So first of all, we have to go into 72, right? We have to move into 72, which is this one, 72, and the ninth column. right? 7.29 is 729. You follow the numbers, right? 729. And you look into the value related to that, which is going to be 8627, right? So it's going to be 0.8627. 5 minus 0.8627. And that's going to be 4.1372. Sorry, 3. Okay, so that's the answer for this one. So let's look at another example. Let's say 0.00579. Let's say we have 4 values now, right? So if we convert this to scientific notation, 5.789 into 10 to the power minus 3. So now convert it to a pH value. pH is equal to minus log concentration H plus. And minus log means it's going to be 3 minus log of 5.789. Now log of 5.789, first we have to go into 57th column, right? 57. 57 is this one. 5.78 and 9. So 8 is this, so corresponding value is this, right? So there's another one. There's another value which is 9, right? So 9 we have to take it from here. Right? So we have to add this 7 into this. So 0.7619 plus 7, right? 0.7619 plus 7 is 0.7626, right? 0.7626. So we'll write this 0.7626 as the value. Then we have 2.2374. 2.2374 is the answer. So there you go. Right? Hari lamai. Then we have to, let's say, like we have to convert a pH value into a concentration value. අපිට තියෙනවා pH value එකක් convert කරන්න to a concentration value. So now what we are going to do? Okay, for example, let's say we have to convert 3.5229. We have to convert 3.5229. Now this is a pH value. Okay, this is a pH value. So that's a pH value. So if you want to convert 3.5229 into a concentration value, first of all, we need to break this down into 2 sections. First of all, this one and this one. So we have the 3, we have the 0.5229. Okay, 0.5229. And we are going to take this 0.5229 and then we are going to subtract it by 1. Again, like 1 minus 0.5229, we are going to find the answer for that. Right? 0.5229, when you subtract, you get 0.4771. 0.4771. Okay. So 0.4771 is 1 minus 0.5229. Now we have 3 value here. That's going to be a 10 to the power minus 3 value. This is going to be a 10 to the power minus 3 value. Okay. Now you find the antilog of this. You find the antilog of this. So 0.5771, I told you it's going to be 3, right? Right? Log 3 is going to be 0.5771, right? So now what you do? You write this value 3 into 10 to the power minus 3. So that comes from here. So this is the overall procedure of how to convert a pH value into a concentration. So let's look at another example. The second one. So let's say we have to convert 4.3010. We're going to break it down into 2. First of all, 3010 separate 0.3010. And this is 4, right? So 4 we can write it as 110 to the power minus. Sorry, previous one, we have to do a small correction there. We have to add 1 to this. I forgot that. We have to add 3 plus 1. Right? We have to add 3 plus 1. 3 plus 1 is 4, right? So it's going to be 10 to the power minus 4. 10 to the power minus 4. So the pH value is 310 to the power minus 4. Sorry about that. It's a mistake. We have to add 1 to it, right? Okay. So here also the same. We have to add 1 to it. So we can write 110 to the power minus 5. And now we do the thing with this one. We have to subtract 1 by that value. 3010, which is equal to 0.6990. 0.6990, we have to find the antilog. The antilog of 0.6990 is 5, right? So you write 5 into 0.6990. 5 into 0.6990 is 5. 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 5 10 to the power minus 5. Now, how to find antilog? The antilog hoan using a logbook. So let's say we have to find the antilog of 0.6729, right? 0.6729, we have to find the antilog. So what we're going to do, we're going to go to the value 6729. We're going to go to the value 6729. For example, now 6730 is there, but 29 is not there. We can go for the least value than this one. 6721 is there. So we're going to look at the values corresponding to it and write them down separately. So we have 47. We can write 47 here. And then the corresponding value for that, 0, right? 470. 470. And we have to subtract. Now 6729 is the value we want, and the value we have here is 6721. And that's going to be 8, right? So we're going to look for the number 8 here. There you go. We have the number 8 there. So the value corresponding to that 8 is 9, right? The column is 9. So we can write 4709. And we look for the decimal value. It's going to be 0.6729, right? So when it has a 0 point value, we write the decimal point here, right? We write the decimal point here. So the antilog of that value is 0.4709. Right. I hope you understood that. Let's look at another example. The final example. Now let's say we want to convert 3.3979 into a log value. So we first of all, we take this out and write 0.3979. And this value, we write it as 3. And we add 1 to it, plus 1, which is going to be 4. And then 4, we write it as 110 to the power minus 4. Okay. And then this value, we can write 1 minus 0.3979. We can write it by subtracting, right? So we can have it like 0.6021. 0.6021, right? So then we find the antilog. Right? The antilog of 0.6021 is going to be 4, right? Right. Then we can write 4 into 10 to the power minus 4. So minus 4 comes from here. So this procedure, try to remember it, because just 2 months to the exam, and these kind of things you need to know, because PH MCQ is definitely coming in your LL paper. So yeah, that's it. So do the questions in the tute. There are some example questions also in the tute. Do them as well. I'll be discussing this in the class again very shortly. So you have to watch this and come to the class.